know how to find the mean and the variance of a regular data set like this? Let's say you have xi. The data set we used last time was this 3, 6, 4, 9, and 8. I already know how to find the mean and the variance of this data set. So if this were a population and I were looking for variance, the formula that I would use is summation xi minus mu squared. Let me just kill this echo. Hang on one second. Audio. And this is mic number D. Okay, so it would be summation xi minus mu square divided by n. And if it were a sample, the sample variance, this is the population variance. So the sample variance would be summation xi minus mu, actually xi minus x bar, because we don't call it mu anymore for a sample, squared divided by n minus 1. We mentioned that this was due to Bessel's correction, right? And of course the mean is just add them all up and divide by however many there are. What now if I have data that looks like this, 0 to 10, frequency 2. So you see that this now is no longer an individual frequency table. It's a grouped frequency table where the first bar, the first class, 0 to 10, has a height of 2. And the next bar, 10 to 20, has a height of 5, and so forth. How would I find the mean and the variance of this data set? So first of all, the assumption is that all the data occurs at the class mark, which is the midpoint. So it's as though these two values, I know the frequency is 2, but I don't know what the data value is between 0 and 10. So I'm assuming that this data value is a midpoint, which is 5. And then the next midpoint is 15, because that's the midpoint between 10 and 20, and so forth. So the assumption is that all 5 of these values are 15s, and all 8 of these values are 25s. Follow me? So once I do that, I can list it as an individual frequency table. So here I have listed the midpoints. The midpoint here is 5, 15, 25, 35, 45, and 55. And here's the frequency column. I can now disregard this column right here. And then I'm using, instead of the old formula that says x bar is equal to summation xi over n, instead of this formula, I'm going to have to modify this a little bit because each of these midpoints occurs multiple times now. So this would be 5 times 2 plus 15 times 5 plus 25 times 8 and so forth. So it's MIFI, because I have to take into account the multiplicity, divided by n, but n here is just the sum of the frequency column. So n is equal to summation fi. Nobody is doing this by hand. Why would you, right? You're going to stick this in your calculator and you will put the midpoints in one list and the frequencies in another list. And then stat calc one variable statistics on L1 comma L2. Did we show you how to use the calculator to find standard deviation for a single row of data? Yes or no? Do you know how to use your calculator to find standard deviation? No? Let's do this. First, let's take this data set right here and find the standard deviation. So if you could pull your calculator out, please. So first thing I'm going to do is stat clear list. Clear list L1 and L2. Let's make sure we have some empty lists to work with. So stat clear list is the fourth one down. L1, so second and the 1 key, comma, second function and the 2 key brings me to L2. And I hit enter. And now when I say stat edit, I should have a couple of clear lists to work with. So just go and put your data in. So after you do this, you're going to say stat edit and input your data. So this would be 3, 6, 4, 9, and 8. And then if you have a fancy version of TI-83 or the latest TI-84, it's going to ask you for the frequency column also. My frequencies are all 1 because each of these numbers only occurs one time. If you have one of those latest, I don't know what it's called, silver edition or something like that, make sure you put 1s in the L2 because you may need it just to manipulate it to work, okay? So I don't think I need to do anything with mine, and mine is at least 20 years old. So I would go stat, calc, and then one variable statistics is already highlighted for you. Just hit enter. And then it says what list. It's waiting for you to input the list. My stuff was in L1. So second function and the 1 key. And hit enter. And I'm done. Like I said, if you have the latest version, it will ask you for what's the frequency list. You should say L2 and put 1s in the L2 list. Is there anybody here who has a calculator on them and cannot get these numbers to work? So I see 2 different values. I see sigma equals 2.28, and I see S equals 2.54, where S is always going to be bigger than sigma because S has a denominator of n minus 1, and sigma has a denominator of n. So S will always be larger than sigma. So this shouldn't be an issue. Let me know if you have any questions. Yes? Comma, right here, under the word sign. Why do you need a comma? Oh, this? Okay. So now let me do it for my data set. This is my data. Here are the midpoints, and here is the frequency column. So let me clear my list L1 again. Stat, clear list, L1, because my L1 has other data in it. Hit enter. It says done. Stat, edit, and then go put into L1 5, 15, 25, 35, 45, and 55. These are the midpoints. And then into L2, you put in the frequency. 2, 5, 8, 9, 5, and 1. And then stat, calc, one variable statistics on second 1, that's L1, comma, L2. Meaning the first column is the midpoints and the second column is the frequencies. And you hit enter and it gives you the mean of 29.33 and a standard deviation of 12.50, 12.51. So if you were doing this by hand, you would have to make a modification for the standard deviation and the variance formula also. So if you start with your old formula, which is this, S squared equals summation xi minus x bar square over n minus 1. First of all, this would change to midpoint, because we're taking the midpoint of the bar. And this would change to summation fi. And then each one is happening many times, so you would have to multiply this by the frequency. So mi minus x bar squared times fi divided by summation of the frequency column minus 1. So this formula would change, but if you know this one, you can get this one by just realizing that you better times by the frequency, because this deviation squared is occurring this many times. You're not going to do this by hand, though. You're going to stick it in your calculator, correct? So the calculator will do that for you, as long as you remember to say stat calc 1 variable statistics on L1 comma L2. You cannot forget this comma L2, because if you do, it will not read the multiplicity. It'll only read this column. If you don't say L1 and L2, it will only read this column and never do the multiplication by the frequency. It won't realize that these numbers are occurring many times. Follow? So would you go make sure that you can get the results, okay? Because the one question on your exam, when it asks you for the variance, you don't want to get that question wrong because you don't know how to put it in your calculator. That would be a damn shame. Question? I know you do. You just have to ask it.
How do you input the data?
So you go to Stat, Edit, and then go to the top of that column and put in this data into L1 and this into L2. So you just hit enter in the middle of everyone. So 5, enter, 15, enter, 25, enter, 35, enter, 45, enter, and so forth. You know what I mean? Hit enter in the middle of each of these. Yeah. How do I know variance what? I'll tell you. I'll say for the following sample, so it'll say group data for a sample is this. Find me the sample variance. So on the homework it doesn't say, but on the exam it will specify clearly. And if not, then just call somebody over and say sample or population. It's not going to happen. This exam's been taken before. It's not a big deal. Okay. Any questions on this? So what if you encounter some multiple choices that look like this? A, B, you know, and it'll have some numbers there, C, D, E, and then it starts again with capital A, capital B, capital C, capital D, capital E. Is this going to freak you out? It shouldn't. If you choose this one, just color in C. If you choose this one, just color in E. That's all. Only one of the E's will make sense for your answer. Are you understanding me? Are you understanding what I'm saying? No? So I'm saying that little e and capital E are colored in as E on your Scantron. Whether it be capital or whether it be lowercase, just color in E if you pick E, because one of the E's doesn't make sense as the answer. So you don't have to worry about me not understanding which E you chose, because one E is going to make no sense. It's not going to be relevant. Follow? So that's the one question that people ask me. They call me over and they say, well, how do you want me to color this in? There are 10 choices. Just color in E as an E and don't worry about it. It'll say that on your exam as well. I'm going to move on unless you have a question regarding this. What? You're looking at one another. Ask me. What don't you understand? Pardon me? You got it? Okay. Do you have any questions about this? Otherwise, let's move on. Did we talk about coefficient of variation in this class? Let's say I have two data sets, One has to do with the baby's temperature, and one has to do with the baby's blood pressure. And they have absolutely nothing to do with one another. The units are different and everything is different. But the question is, which data set is more variable? So I have a bunch of numbers here for x. This is some variable x and some other variable y. In order to figure out which one has more variation in it, it is not sufficient to look at just the S value. S, as you know, is standard deviation, and it talks about how variable, how much the data on average varies from the mean. It's not sufficient just to look at S. You will have a S for this one, and you will have a S for this one. You cannot just compare these two S's. One is in blood pressure units and one is in something else units, and they have nothing to do with one another. They cannot be compared. What you will do is divide this S by X bar, so that when you divide S by X bar, the units will drop because the standard deviation and the X bar will have the same unit, times 100. This is called the coefficient of variation. So find it for x and find the coefficient of variation for y. S y divided by y bar times 100. Now you can compare it. Let me give you an example. So this example comes from this packet that begins with page 1 that looks like this. I believe it's the very last item on your blackboard. It says items you need to know, something like that, things you need to know for exam 1. It's the very last set of class notes, and I think it's in there. Yeah, it's on page 3. And in the typed notes, it's on page 24. So they give you two sets of data. The standard deviation here is 12. And the standard deviation here is 0.2. So you are not to look at these two and compare them, because they cannot be compared. You have to divide 12 by 80, which is 15%. And you would divide 0.2 by 0.5, which is 40%. So this one has a higher coefficient of variation, and therefore more variability in this data compared to this one. It's only good for ratio scale variables. Only for ratio scale variables. Because if a variable is not ratio scale, it doesn't even make sense to divide S by X bar. Right? If you cannot take ratios, then how can you perform the division? So it's only good for ratio scale. Any questions? You know that this means summation, right? And you know that this is lowercase sigma, this is uppercase sigma. And what about this one? What does that mean? Pardon? Yeah, pi, not 3.14. I'm not interested in that. What does the capital pi mean? Yeah.
It's kind of like a summation, but we multiply everything.
It's a product, right. Right. So where did you see this? Let me remind you. When you did geometric mean, x bar g for geometric mean, we took the product of xi, and then we took the nth root. You remember that? Remember when you did we talk about geometric mean in here? We had to have, when we talked about interest rates and what is the annual interest rate that applies over n years, right? Yes or no? So that's when you would see this. So let's say that xi are 3, 8, and 9. So x bar geometric would be 3 times 8 times 9 and you would take the third root because there are 3 numbers. You would take the cube root, right? So that would be written this way, the product of the xi's. And then you're taking the nth root because there are n numbers. Follow me? Okay. Okay, the next thing I want to talk about are these formulas on page 24 in your typed notes. So, do you recall last week that we said something to this effect, yi, if yi is equal to xi plus c, then y bar is equal to x bar plus c. Do you remember that? That if every data point is increased by a constant, then the mean goes up by the same constant. And I believe the example that I gave you was this. xi is 3, 4, and 5. I'm adding 10 to everybody. So I got 13, 14, and 15. And here the mean was 4, and here the mean is 14. So clearly the new mean is equal to the old mean plus 10 also. So this is demonstrated by these two right here. Do you see that? We talked about this last week. Today I want to talk about what happens to the standard deviation of y if you add 10 to the entire data set. This stuff is on page 24 of the typed notes. Can you think about it and let me know? What do you think happens to the standard deviation if I add 10 to every data value? Well, one way you can do it is stick it in your calculator and find the standard deviation of 3, 4, and 5, and then in another list stick in 13, 14, and 15, and let me know what happens. A second option is to think about it. What do you think? Here's 3 numbers, 3, 4, and 5. 3, 4, 5. What's the mean of 3, 4, and 5? 4? I've decided to add a constant of 10 to everybody. So add 10 to 3, you're going to get 13. Add 10 to 4, you're going to get 14. And add 10 to 5, you're going to get 15. The new mean is 14. I already know that from last week, right? Today I'm asking you, what do you think happens to the standard deviation, where the standard deviation is the amount by which the data varies from the mean on average? That's the definition of standard deviation. How much does the data vary from the mean? Stays the same, right. Is it clear that the amount by which this and this vary from here is the same amount by which this and this vary from here? Because all I've done is slide the entire distribution 10 places to the right on the number line, but how much things vary from the mean is not impacted because the entire distribution has just been slid to the right. Are you with me? So SY, which is the standard deviation of the new set of data, is going to be equal to SX in this case. Let me know if this doesn't make sense and I'll show you mathematically. Look at this. XI is 3, 4, and 5. The mean was 4, right? So my deviations column would be xi minus x bar, where x bar is 4. So 3 minus 4 is negative 1. 4 minus 4 is 0. 5 minus 4 is 1. They add up to 0 because they better add up to 0, otherwise there's something wrong with what you've done. Xi minus x bar squared is 1, 0, and 1 for a total of 2. So Sx is equal to summation xi minus x bar square over n minus 1, which is 2 over n minus 1, where n is 3. So n minus 1 is also 2. So Sx is 1. Now if I do this for 13, 14, and 15, look what happens. This is a 13, this is a 14, and this is a 15. The mean is now 14. So I get exactly the same set of deviations and the same set of deviation squareds. So obviously Sy has to be equal to that as well. Follow me? Any question? So Sx squared is equal to Sy squared, which are the variances, the sample variances. So the sample variances are the same and the sample standard deviations are the same if you add a constant to any data set. Make sense? Or no? Yes or no? Do you have any questions? What if the constant is negative? I say, who cares? Instead of sliding it to the right, you're now sliding it to the left. But the mean increases by that constant. So the new mean, let's say my constant was minus 10 instead of positive 10. Now the new mean would have been 4 minus 10. Right? And the amount by which the observations vary from the new mean would be the same as the amount by which the observations vary from the old mean. So nothing changes even if the constant is negative. Let's go to the next rule on page 24, which says if yi is equal to cxi. Actually, I need you to make a change on this on page 24. The way it stands now, it says this. If yi is equal to c times xi, and if c is a positive constant, then sy is equal to csx. Does it say that? I'm on page 24. And it should say sy squared is equal to csx squared, which is the variance, right? Does it say that? It doesn't even say that? C squared. C squared sx squared. So I would like you to make a change on this. C does not have to be a positive constant anymore. Nobody said that C has to be positive. This would work for any C. And you have to make a change for the standard deviation. The standard deviation would be the absolute value of C times Sx. So if C is a negative constant, let's say that I'm multiplying my data by negative 10. So I'm starting with xi, 3, 4, and 5. And I choose to multiply by minus 10. So yi would be minus 30, minus 40, and minus 50. So when I have 3, 4, and 5, what do my deviations look like? Xi minus x bar look like 3 minus 4, 4 minus 4, 5 minus 4. They add up to 0. And then xi minus x bar square is 1, 0, and 1, and the sum is 2. We know that, right? Let me do the same thing for yi. So yi minus y bar, where y bar is negative 40, is negative 30 minus negative 40. So this deviation is a 10. Minus 40 minus minus 40 is 0. And minus 50 minus minus 40 is a negative 10. So this deviation column would add up to 0. Are you with me? Square them. yi minus y bar squared, 100, 0, 100. Add them up, you get 200. So the formula here would be sy square is equal to summation yi minus y bar square over n minus 1. That's the formula for variance. So this would be 200 over n minus 1, which is 2. So I get 100, which is the variance for this one. So do you see, let me do it for this also. So Sx squared is equal to summation xi minus x bar square over n minus 1. So this would be 2 over 2, which is 1. So Sx squared is 1. So I see that Sy squared is equal to 100 times Sx squared, where 100 just happens to be c squared, right? So Sy would be the square root of Sy squared, which is the square root of 100 Sx squared. So it would be 10 times Sx. Not minus 10 times Sx, but absolute value of minus 10 times Sx. Sx. Follow me. Question? Who has a question about what I've done? I'm trying to show that this works when I multiply by every data value by negative 10. And I have shown it because my new standard deviation is 10 times my old standard deviation, not minus 10 times my old standard deviation. Follow or not? If you're totally lost, can you let me know? Okay, and the third rule would say this: if yi is equal to c1 xi plus c2, what do you think happens to the mean and what do you think happens to the standard deviation? The mean we talked about last week, right? Tell me the rule again. What happens to the mean? Should I put numbers in? Yi equals, let's say, 10 times xi plus 100. Let's say. Can you tell me what the rule would be for the mean? Are you stumped, or is this so ridiculously easy that it's demoralizing? Answer me, please, people. You're not giving me an answer, and yet you're not asking me any questions, so I'm at a loss. Y bar would be 10x bar plus 100. Of course it would, right? Because the mean follows the same pattern. So now can you tell me what happens to the standard deviation? Doesn't change? Right. So Sy would be absolute value of 10, which is just 10, times Sx, using this rule. But we already know that sliding to the right doesn't change the standard deviation, right? So this 100 would have no impact. Follow or not? So now, can you tell me what happens to the coefficient of variation of each? I would like to discuss what happens to the coefficient of variation of y if every data point is multiplied by 10 and you add 100. Do it now and tell me. This happens to be one of the questions on your pretest B, which means you'll see it on your exam. I want to talk about the coefficient of variation of x, and next I want to talk about the coefficient of variation of y. Work on it, let me know. Are they the same? Is one 10 times as big? What do you say? I want to know what is the relationship between the coefficient of variation of x and the coefficient of variation of y. Is one 10 times as big as the other, or are they the same, or some other relationship exists? Tell me. Go ahead. It is 10 times bigger? I don't know if it is. Let's see. Coefficient of variation of x is Sx over x bar times 100. And this one is Sy over y bar times 100. Right? So I happen to understand that Sy is equal to 10Sx. So I'm going to replace this Sy by 10Sx. So coefficient of variation of y is 10Sx, that's Sy, divided by y bar. I also know that y bar is equal to 10x bar plus 100. And then I have to go in times by 100. That's this 100. This formula comes from here. Agree? I want to know if there's some relationship between this one and this one. If I factor out the 10, what happens? I get 10. Well, let me factor 10Sx over 10 x bar plus 10, like this. These 10s will drop. So on the left-hand side, I have Sx over x bar times 100. And on the right side, I have Sx over x bar plus 10 times 100. So are they the same? No. Is one 10 times as big as the other? No. Which one is bigger? Which one is bigger, this one or this one? The first one. The first one's bigger because the second one's being divided by a bigger number, so the quotient will be smaller. So I cannot come up with a relationship. It's not a 10 times relationship and it's not equal either. The answer is coefficient of variation of y is equal to the standard deviation of x divided by x bar plus 10 times 100. Follow me? Any question? So have you had a chance to look at pretest A and B? Have you had a chance to look at the old exams? You need to, you understand that, right? So pretest A and B should be, you should know those answers cold. They come with complete solutions. And the old exams you should go over. The more problems of those that you do, the higher your score will be. So please make sure you do that before your exam, which is on Tuesday, right, of next week. Okay. We talked about z-score. Do you know this formula? Yes? We talked about biostats and epi and how she did worse in epi, right? Okay. So I believe we've covered everything in this packet then. We just did this today. We've talked about modified box plots. We've talked about percentiles, right? Let's review a problem with this and then I'll move on. Let's say I give you the following data. Minus 30, 3, 7, 10, 11, 12, 90, 100. 1, 2, 3, 4, 5, 6, 7, 8 data points. Can you find me Q1, Q2, Q3, and the modified box plot? Can you also find me the fourth decile? Fourth decile is what percentile? Right, this is P40. So understand that this data has been ordered for you, but on the test it may not be in order. So you would first order the data. Should I give you a chance or should I just do it? Do it? I should do it? Okay, I'll be happy to do it. So I have 8 data points. The first one I'm looking for is the first quartile, which is P25. So I'm going to take N times P over 100. So this is 8 times 25 over 100, or 1/4, right? So this gives me 2. 2 is an integer. So take the average of the second and third ordered values. That's the rule, right? When you arrive at an integer. So I'm going to take the average of 3 and 7. 3 plus 7 divided by 2 is 5. So Q1 is 5. Agree? Do you have any questions with that? The reason why I'm taking averages is because I arrived at an integer value, and the rule is when you arrive at an integer, you will take averages. When you arrive at a non-integer, you round up to the next integer. So because Q1 is the average of the second and third from the left-hand side, Q3 will be the average of the second and third from the end of the data set, right? So Q3, which is P75, is equal to 90 plus 112 divided by 2. So 202 divided by 2, which is 101, is Q3. Q2 is equal to n times 50 over 100, which is 4. That's an integer, so take the average of the fourth and fifth ordered values. So that would be the average of 10 and 11, which would be 10.5. So when I draw my modified box plot, this is what it looks like. I start at negative 30, and I end at 100. So negative 30, negative 20, negative 10, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. The min is, well, it's modified, so I have to be, did I make a mistake? Oh, I'm sorry, it is 12. It is 12, I'm sorry. 90 plus 12 divided by 2. So 102 divided by 2, which is 51. Thank you. So Q1 is 5. Thanks a lot. Q1 is 5. Q2 is 10.5. And Q3 is 51. Next thing I do is find the lower and upper fence. So the upper fence is equal to Q3 plus 1.5 times the interquartile range. Let's first compute the interquartile range. So IQR is Q3 minus Q1. So Q3 is 51 and Q1 is 5. So 46 is the interquartile range. And 1.5 times 46 is 69. 1.5 times IQR is 69. So I need to go a distance of 69 to the right of 50. So that would be 119. So it would be out here. $110, $120, so $119 would be out here. That would be the upper fence. And the lower fence would be Q1 minus the same 69. Q1 minus 69. So Q1 was 5. 5 minus 69 is negative 64. So it's somewhere out on the left side. I don't really have any data values to the left of minus 30, so nothing is going to fall to the left of the lower fence. Agree? So my issue was, will this 100 fall outside the upper fence? And the answer is no, it doesn't. So in this data set, there are no outliers. The maximum is 100. That 100 is within the upper fence. And on the left side, it just goes down to minus 30. And again, there are no outliers because the lower fence is at minus 64. Follow me? So here's my box plot as well as the modified box plot. What kind of skewness? Right skewed, right? Just go like that. Right skewed. Yeah, sure. So here, lower one is Q1 minus 1.5 IQR. So 1.5 IQR is 69. The Q1 was 5. So it's at minus 64, which is to the left of any data value that I see. Get it? So the same thing that happens here, the same thing that's happening here where the upper fence is here and there are no outliers, the same thing happens on the left-hand side. So you wouldn't see any outliers anywhere. This is all you would see on the modified box plot. It's just I who draws the dotted line. You're not going to see that if you have Excel or SAS draw the modified box plot. It would just look like this. It would look like something like this. There's not going to be any dotted lines like that. There never would be a dotted line. It's just I draw the dotted line so you can see where the upper fence is. Okay, so any questions on this? Yeah. What did I make a math error? Is that what I did? It's 119, right? Let's see, where am I? Upper. So Q3, I use 50. Yeah, what is it? 51? Yeah. Okay, so where did I write it though? Here? No. Did I write it anywhere? Or I just did it in my head? These are the only two papers I had, right? So upper. Okay. So 120. Okay, thank you. 51. You know what I think I did? I think I just looked here and saw the line at 50 and I added it to 50. 51. You're right. 51 plus 69. So 120. So 120. Yes. 120. So no issues with this, right? Okay. So on your test, it'll say, find the upper fence, find the lower fence. Are there outliers? Just like that. Any questions? Let's move on to the next, this packet. This packet contains a bunch of stuff that I want to make sure that I have mentioned in your class. So when you have a right skewed distribution, such as this one, the median, of course, is the middle value, which is P50. The mode is the value that occurs most frequently. So when I draw a right skewed distribution, the mode will happen where the height is the max. The median happens where you divide the area into two equal pieces. But it is the mean that is not robust, so the mean will get dragged up in the direction of the outlier. So that's why it says here, the mode, which should be here at the highest point, then you would have the median, and then the mean. The mean, unfortunately, gets dragged up by these high values. I only have a few high values, but nonetheless, they will drag the mean up compared to a distribution like this, where the mean and the median and the mode are all in the center. So this mean that used to be up here will be the largest value in this distribution. Similarly for this one, the mean gets dragged down, The median divides it into two equal areas. The mode is where the frequency is the highest. No issues there, correct? Next one. Make sure that you understand that the mid-range is the min plus max divided by 2. It's not the range divided by 2. It's the average of the min and the max. You have to know that class mark is another word for class midpoint, where you're just going to take either the lower class interval and the upper class interval and average them, or the lower class boundary, which would be here, plus the upper class boundary, which is, remember we moved this a half over and a half this way over? So I would take these two and average them. Either way you would get 7. Whether you're averaging 4.5 and 9.5, or whether you're averaging 5 and 9. That's the class midpoint, which is otherwise known as class mark. This stuff I did today, right? Where if I add a constant to every value in the data set, the mean goes up by the same constant, and the standard deviation remains unchanged, and so does the variance. So this page was done today. Coefficient of variation I also did today. Putting stuff into your calculator we did today also. Mean of dichotomous data, I think we did a couple of weeks ago, where if you have one that's represented by ones and one that's represented by zeros, then the mean would be the fraction of the population that gets the ones. Do you remember this or not? So suppose you have exactly two types of variables, two values for the variable, male and female. This is a nominal variable, male and female. Assign a 1 to one of them. In this case, I assign a 1 to the males, and I've assigned a 0 to the females. What happens when you take the mean? So normally, nobody talks about taking means of nominal data. That makes no sense. However, if you assign a 1 to one of them and a 0 to the other, now all of a sudden you can take a mean, and on the top you will have each person's either 1 or 0 contribution. The only people making any contributions are the males to the numerator. And then when I divide by n, you get the number of males divided by the total number in the population, which is just the fraction of the population that is male. So just wanted to draw your attention to that. Okay, here's a question that people get wrong on the test. It says that it's a true or false question, if I remember correctly. Let's see. 75% of B exceeds 50% of A. True or false? 75% of B exceeds 50% of A. True or false?
False.
75% of B's distribution exceeds 50% of A's distribution. True or false? Which one and why? It's true. I'm talking about this 75, it's true. I'm talking about the 75% of B being this 75% of B right here, starting here. Since this is Q1, it's P25. That means to the right of Q1 lies 75% of B's distribution. And that exceeds the lower 50% of A's distribution, because this is Q2 that represents where 50% of the data lies to the left of Q2. So this 75% of B does exceed this 50% of A. So it's true. Follow me? Okay, this is right skewed. You know that already, right? You know that the interquartile range is used to talk about comparing variability of two data sets. What if you have 50 males and 70 females, and you want to choose 5 males and 10 females? How many ways can you do it? You would multiply. 50 choose 5 times 70 choose 10. You would multiply them. Don't add them. Multiply them. Let's say you're given a tree that looks like this. A, B, or A and not A, and some number here that says C and not C, C and not C. You understand that this is C given A, correct? Because it's coming out of the A branch. And this is not C given A, right? And these are complements, right? And these are complements also, if there are only 2 of them, right? Okay, just wanted to mention that. We talked about the mean and standard deviation of group data today, right? The stuff that you stick in your calculator. It's that same problem here again. Tells you how to stick it in your calculator. Right here. Mean of dichotomous data again. This is talking about which one has the higher standard deviation. I'm sure we did that in this class, right? It's B who has the higher standard deviation because it varies more from the mean. This is same question, same kind of question. This one varies more than this one because it has more values far away from the mean. The end. So you have now learned everything you need for your exam.